Hey everyone, we'll get started in just 1 second. Give us just a minute here. Okay, well, welcome everybody, and thank you for joining us today as we dive into what AI means to the transportation industry. And I'm thrilled to have three of my colleagues driving the conversation today. From our AI team, we have our Chief Analytics Officer, Juliana Nascimento, and our SVP of Artificial Intelligence, Joe Durante. And they're joined by our Head of Sales, Zach Schukart, and together they're going to be shedding light and really demystifying what exactly AI is doing for the transportation industry. So you can please submit Q&A at the bottom of your screen, and we will try to answer as many of these as we can when we get to the end, and we will do our best. If for some reason we don't get to a question, someone from our team will reach out to you at the end. So 1 sec. So before we get started on transportation, Juliana, there is so much attention and hype around generative AI at the moment, with ChatGPT being the headline grabber. Where does Optimal Dynamics fit into this broader AI ecosystem?
Well, indeed, Scott. But broadly speaking, there is a key partition that we often use to frame AI technologies. So bucket number one is make a computer do what a human being can do, which is a pattern matching prediction flavor of AI. And then we have bucket number two, make a computer do something better than what a human can do, which is an optimization flavor of AI. So OD fits into bucket number two, leveraging bucket number one. So to keep the ChatGPT comparison going, while these pattern matching technologies can recreate work, they can't actually create an optimized work yet. So at OD, we take the pattern matching technology one step further and actually make decisions that are optimizing profitability, service level, driver satisfaction, to name a few. Therefore, doing a better job than what a human being can make. This in addition to all the other benefits that all AI offers, such as increased efficiency, automation, and etc.
Okay, interesting. So Joe, can ChatGPT plan freight then in a trucking network?
Well, not exactly, Scott. It's just not the right AI tool for the job. For one, ChatGPT and these large language models live in a world of big data, whereas trucking is more in the medium or small data space. And I don't think it really applies to the problem, but using concepts like ChatGPT in these predictive model classes like Juliana mentioned, they're very good at seeing what's going on now and predicting what might happen based on your historical patterns. So at best, it can say, well, given how your dispatchers have performed in history, what might they do under this situation? But there's another pitfall. It has to have seen that situation before. And when you run into new scenarios, and that is going to be prevalent in the truckload planning situation, you have hundreds and thousands of drivers at new locations across your network all the time. You have loads popping up in new markets with new characteristics. When you run into these new situations that a technology like a large language model or using similar ideas they haven't seen it before, it will struggle to produce even a feasible plan. Now, if we want to talk about getting better than what humans have done in the past, that's when you need a tool that can also optimize, maybe learning from stuff we've seen in your history, but also optimizing and getting better than what a human can do. And that's the type of technology we have at Optimal Dynamics.
And by the way, this ChatGPT type of technology does not react to real-time changes and readapt itself, right? And this is huge in a logistics world, supply chain world, and dispatching world. You need to react all the time to real life happening to you.
So Joe mentioned tooling. So Juliana, then what type of AI tool are we talking about at OD?
So I want to give technical terms here. Technically speaking, OD technology is a combination of reinforcement learning, optimization, and simulation. Large language models is the name of the technology behind ChatGPT. As mentioned before, these type of models are only predicting the most likely outcome to come next. It's not optimizing your full network, taking into account interactions of several drivers and loads. In our world of dispatching, for example, ChatGPT technology can be used as input to the optimization. Let me be concrete. We can use ChatGPT to predict how likely it is for a driver to accept each load that could possibly be assigned to him, and use this likelihood as one of the many factors that go into the optimization to decide which loads will actually be assigned to each driver. So that's why the technology that we're talking here.
Gotcha. Okay. So what we're really talking about is an optimized decision automation for these vast networks. So Zach, let's talk about the industry then. Why is this so applicable to a trucking network in particular?
Yeah, thanks, Scott. Yeah, so I mean, if you think about, applied math and what it means to the industry, let's first take a step back and admit that the vast majority of us, even of the most mathematically inclined, get out our iPhones to do very simple math, right? So what we're asking planners and dispatchers to do is a monumental task, right? Their networks of loads and drivers is a vast array of variables and decisions that they need to make on a daily basis, right? So if I accept this freight today and plan it for this driver tomorrow, how does that position the asset and the driver in the network in the future to maximize utility, maximize revenue, or maximize revenue per truck per week if we're using metrics like that, keep that driver happy, right? Keep them in the mission that we agreed as an organization to keep them in. And really, so the planners and dispatchers are quickly and manually currently having to make a decision of what is the incremental value of this load in the future. They're doing that for every load and every driver at scale. So what's happening is they can't simply, a human can't simply absorb the math that's required to scientifically place a value on that load in the future. So what happens is we use intuition, right? So the more tenured planners are overseeing the planning floor, the more tenured dispatchers are overseeing the dispatching floor, and they're using tribal knowledge. They're using what they know about their organization to overlay their gut feeling into the decision. And oftentimes it's the right decision, but when we talk about the optimal decision at the load level, when we scale that up to a network, it is a significant impact that using a solution like this can make on an organization.
So I think what would be interesting now for everyone is, Joe, let's talk a little bit like what is actually going on in the OD AI engine to do as Zach just described. So how does all of this actually work?
Sure. So the OD AI engine is a flavor of reinforcement learning and stochastic optimization. And to break that down in perhaps simpler terms, at the most basic level, what we're doing is repeatedly optimizing and simulating your network, and then learning about those simulations to provide better and better recommendations the next time around. So we take in all the data about your network, stuff that's happening today, stuff that's happening yesterday, stuff that happened a year in the past, and use this information to generate scenarios of what might happen in the future. We use our forecasting technology to build models, and then we sample from those models to generate simulations of the future, scenarios of the future. And then we repeatedly optimize right now and simulate decisions in these scenarios. And we learn about decisions that produce good outcomes, good behaviors. And that could be stuff like delivering loads on time or having highly profitable tours. And we're going to, over iterations of the algorithm, reinforce that stuff happening more and more often. This is why it's a flavor of reinforcement learning. And then we're going to look at decisions that resulted in bad behaviors, like drivers missing time at home events, or let's say idle drivers across your network. And we're going to trim these out iteratively from your solution. So we do all this learning offline, and then when we go deploy it into the field to make decisions in real time, we're just continuously deploying the most up-to-date information we've learned about your network, doing this offline training. And then in real time, we take into account new information that we see, like the current state of your network, the current state of your drivers, your loads, your trailers. And we combine this with the offline training that we've done to provide network plans, dispatch decisions, load acceptance decisions to your dispatchers and network planners in real time.
So we are ingesting a bunch of data, running analysis on that data. Juliana, what types of data is the algorithm actually taking in?
Okay, so I'm going to give more details about the types of the data and also how often we ingest them, right? So for this discussion, it's important to keep in mind that we are managing three resources here. Our systems managing three resources: drivers, loads, and trailers. We need to learn historical patterns about these resources, these networks. We need the setup data related to these resources. We need to understand your business preference and rules, and we need real-time information about these resources. So concretely speaking, so for example, historical load information, booking date and time of your loads, origin, destination, stops, appointment types, shipper, revenue, commodity, what are requirements to move that load? For example, what is the equipment type, driver permits, or certification? And by the way, it's also very useful, if available, if we get the loads that you didn't move, that were tendered to you and you reject. It's give us a lot of information. We also want your historical dispatching history. So this historical batch data is ingested once. Let's say it's 1 year worth of historical data. We grab this from you. Then we need to ingest setup data. Let's say profile of each one of your drivers, their home terminal, their preference on when they need to be home and how often, length of haul that they are allowed to drive, how they are paid, if it's cost per mile, cost per time, percentage of revenue, what are their permits. We also want the profile of your trailers. We want other direct costs associated of assigning a driver to a load. We want other direct costs associated with assigning a trailer to a load. We want to know about your contracts and awards. If you do have relay yards and what are their locations, if you do have trailer pools and what are their locations. We want to fine tune to your business. So we need rules that must be followed. For example, certain drivers cannot go to certain regions. Certain drivers cannot be customer facing. They can only drive in and out of relays. We also want average loading and unloading times. We can have it broadly, and we can also fine tune to certain facilities. And we will need parameters that will guide the optimization to follow this business preference. For example, we are always optimizing for profitability. But for example, is service level more important than your driver utilization for your business? How do you rank them? And then there is a calibration process to tune these values to match to your operation. So this calibration process, it's a mix of historical data, user input, and KPIs obtained by the simulation and historical data. So all that I have mentioned so far, this is setup data. This is ingested once, once it's ingested, adjusted, and settled, it doesn't change often. It can change. You can add or remove rules. You can change costing. You can add a driver profile, but it doesn't change often. Then we go to real-time data. This is the data that we keep receiving, let's say, every 5 minutes and reoptimizing for. Where are your drivers? GPS location. Where is their current HOS DOT clock? This is the information coming from your ELD. Which loads are in progress with which drivers? Where are they going to be dropped off? What loads are already pre-planned and assigned to drivers? Which loads you need to create a plan for them? Where are these loads located right now? Where are your trailers? Which trailers have been pre-planned, pre-assigned to loads? So this is information that keeps coming and new loads that keep being tendered to you. So we keep this information coming and we keep adjusting and generating load acceptance recommendations and dispatching recommendations to you.
Yeah, I think it's also important to call out that, you know, when you talk about profitability and service, in the math world, we use objective function, but really what that means is we are building into the system what makes a carrier's individual differentiators to their customers operate, right? So the objective function is really what means the most to you. It could be service for certain customers, or it could be maximizing revenue. And we're able to tune the solution to make decisions that really drives towards the fidelity of the objective function.
Yes.
And so Julian, you mentioned, and you're talking about real-time data, and you mentioned this a little bit, but if you could drill down a little bit more, what when you're saying reoptimization, talk about that a little bit more. What's the systems doing in terms of reoptimizing?
Yes, I'm talking about dispatching decisions here. So as new information becomes available, we reoptimize the dispatching decisions again. However, as practitioners, we understand the importance of predictable, executable plans. So we can put an emphasis on sticking to the previous plan if possible, but reoptimize if necessary. For example, once the ETA of a load in progress suggests that the driver moving that load has a high chance of being late for his next assignment, the system will determine if it makes sense to disrupt possibly more than one plan that is already in place to better serve that load, or should we stick to the plan? Because usually companies might assign pre-assign loads to drivers. Drivers like to have this visibility, but plans can change and we can help with that to make this decision. When should we stick to plans and when should we change plans and when should we tender? When should we assign, increase this tour for drivers? So we keep providing options.
So this sounds like we're taking in all of this data, and all of this data is what is required, and all of this analysis, I should say, is required to make the best possible decision, you know, for a load at that moment in time. Zach, that doesn't seem reasonable to ask an individual or human being to do that. Is that what's happening today?
Yeah, I mean, is it reasonable if we really think about it? No, but we do it. And, you know, the vast majority of carriers and logistics providers are out there doing that. And it's a management by brute force scenario because there's no other option, right? And when we start to talk about making resilient decisions, the more resilient sometimes the decision gets when a human makes it, the more conservative that decision gets, and they start to lean or start to bias themselves into protecting the network or protecting how the company operates. And they lose sight into, you know, hey, this is not a bad decision. You're just not seeing these other loads that you know you would not see because we're predicting these loads to come up, you know, 2, 3, 4, 5 days into the future. So again, when you start to look at the totality of all the information that's available, you know, it's simply impossible for a human to really look at hours of service, you know, load cadence coming in from customers, absorb all that, make a decision on a load, and what that load means incrementally in the future to the network at scale.
But well, sticking with that for a second, then, so what are I'm assuming, there's integrations. What are we actually, what is our system actually ingesting? Where is it getting the data? What are we integrating with?
Yeah, so the two sources of truth that we integrate to within a customer are the TMS and the ELD. So we are not a TMS provider. We are not an ELD. We take signals from those real-time signals from those two sources of information and help support decisions for planners and dispatchers. So, when you talk about, the information coming from the TMS, it's not just taking just this massive swath of information and kind of just bundling it together and making a high level or deterministic optimization decision. We're really looking at, what the customer order profile is. If we have a customer that we have committed 30 loads a week to in this lane, when do those loads come in? Is it evenly distributed throughout the week? Or does 95% of these loads drop on Wednesday and Thursday? And how do we position assets and drivers in our network to be able to make the best decision, make the best load decision that maximizes revenue and the objective function that we're really trying to drive to?
Gotcha. So let's, Joe D, I'm going to throw it back to you for a minute. So we're taking in data, we're ingesting it, we're analyzing it. You talked about previously, the engine is optimizing and then simulating the network. Let's break this down a little bit and go into a little more detail on what kind of each side of that means. So let's start with the optimization part. What does an optimized plan or optimized load plan mean in this context?
Yeah, sure, Scott. And this is exactly why we need that laundry list of about 75 things Juliana mentioned early on, because we need to create. The engine has fundamentally the same task as a dispatcher, given the available drivers and given the loads and the loads that need to be moved in a certain chunk of time under a certain set of constraints and objectives set by a company. What is the most optimal plan? So breaking this down even further, so we have a set of KPIs we're trying to achieve. We can look at each potential driver to load assignment and say, well, how much does that potentially benefit the network in terms of the KPIs we're trying to achieve? On time, service coverage, profitability, getting that driver home. Is it likely to get the driver home? And we can assign a value to that in terms of your objective. And then we, in accordance with certain fundamental truths about the network, like a load can only be serviced by one truck at a time, or loads with certain certifications can only be taken by drivers with certain permits. So those are our constraints in our world, or other details about the network that Juliana and Zach have mentioned, contracts that must be taken, customers that must be serviced, etc. And we could take all this information, the potential assignments and the constraints, and formulate it as a math problem. And the result of that math problem is the exact right allocation of drivers to loads that optimizes the total network value. And the important point here is it is total network value. It's not the best for one driver. It's not the best for one load. It is the best assignment, the optimal solution for all of the drivers and the loads in the network at the same time.
So then on the simulation side, what are the types of simulations we're running, and what's the benefit of that piece of the analysis?
Okay. Yeah. Oh, that too. All right. So the simulations we're running are scenarios of the future, and they are trained on historical data from your network. So we're doing forecasts of loads that might be booked out into the future. And there's a twofold benefit here. So as I mentioned in the optimization part, we're taking a look at your how each decision impacts your KPIs in your network. One of the things I didn't mention is if we just look at the individual decision here and now today of a driver to load, without considering the downstream impact of where the resource will end up in the future, we're going to have a very myopic look at your network. So using the simulation, we can see if we made this decision and this driver ended up at a future point in time, we can move forward through time, taking steps through time, optimizing, simulating decisions, optimizing, simulating decisions. And just a very concrete example, let's say we have a highly profitable load now that brings you into a freight desert. So we would, in the first iteration of the algorithm, maybe we would choose that driver to load assignment, put the driver there. And remember, this is training. This is not in your live customer instance. Put the driver there. And then after we simulate some of these scenarios, we realized, wait, that driver actually didn't make much profit. It was actually a bad move for the network. We're going to take note of that. And we're going to use observations like that and observations from similar types of drivers to feed that back into the system. So on the next iteration, we include it as a penalty for the original assignment, and it's no longer the optimal assignment. So that's that reinforcement piece. That's how we use the scenarios. And quickly here, the second benefit is that we can incorporate uncertainty. So these scenarios are represent a wide variety of possible outcomes for your network. And so when you're presented with a load acceptance decision that might hinge on a very volatile lane coming into a certain point in space and time, let's say we're trying to accept this load from B to C and it requires a load from A to B show up, and it's a very volatile lane. If we continue to run scenarios and sample from our models, we'll find that maybe this only shows up 30% of the time. We're going to naturally favor a more robust set of decisions that, well, in 70% of our scenarios, this is not going to be a good load to try to force to take. So we're going to favor a more robust set of scenarios using this idea of this would be the stochastic optimization piece of our technology.
So, okay, so Juliana, let's talk about the real world though. So we have customers that are using the solution for 90% of their dispatching decisions. What happens when the real world comes into play? And let's say, for whatever reason, customer has to choose the non-optimized lane or a riskier lane. How does that play back into what we're doing?
So great question. So Joe was giving an example of a load lane acceptance decision. Now we need to talk about the actual dispatching decision, the actual driver that will move that load. Note that we are detaching the load acceptance decision from assigning a specific asset to move that load. So if the planner does decide to move a load in a riskier lane, because, for example, they are bound by contract, between the time that the decision is made and the time that the load actually needs to be moved, new information is going to become available, and the system will recommend decisions to make moving this load less riskier. The closer we are to the pickup date, the more clarity we'll have about the risks, and the system will keep evaluating these risks. In most cases, so if it is a happy case, it was risky, but we could find a driver, and a driver to be there on time, perfect. However, if we fall under, oh, this was not a good idea. In most cases, we can alert the planner dispatcher in advance when we anticipate a dispatching problem, giving them time to act in the best interest of the business. It might mean calling to the customer service of that load, negotiating a different appointment window, or sending the load to brokerage with as much lead time as possible, or dropping another load that is less important to the business in order to be able to serve this. So we are going to reoptimize to make sure that we reduce the risk. However, if we are not able to, if real world happens and we are not able to, we'll be able to give ample time in most cases so the planner can act accordingly and salvage the situation.
And
So
so this
this
is what,
a perfect example of our system working with the humans, upskilling the humans. So we take out the mechanics and we can optimize, and then we give dispatchers and planners more time to deal with these difficult situations when they do arise.
it's always good to work with the humans. I do it every day. So this is what we mean by a resilient system, right, Juliana? This is what we're talking about.
Yes.
All right, great. So I was meant to say at the beginning, we're trying to keep this to around 30 minutes, and we're sort of at that mark. There is a mountain of more we have on this topic, as everyone can imagine. And so what we've actually decided as we were preparing for this was we're going to turn this into a series and go deeper. But for now, I want to turn it over to our last question, and then we'll try to get to some of the Q&A. So shifting gears back to what does this mean, for real customers and prospects, Zach? What does this mean to a trucking company when you adopt a technology like this?
Yeah. So number one, the solution is going to handle the simple math, right? That is going to that most of the loads fall under, right? So computers are very, very good at solving math problems and solving them very quickly. They're not so good at solving human problems, meaning customer service problems. Hey, this is a brand new customer to us. I want to be a little bit more conservative here just to make sure that the relationship is kicked off right, or we're at risk with this customer. I know the optimization is saying, hey, this isn't a very good fit for the asset, but I really need to retain this account right now. So that's one. Secondly, and one that we're seeing drive a significant amount of ROI for our customers, is it really breaks down the silo between the asset and the non-asset side of the business, meaning the asset side or the brokerage. And if you have a solution that can actually sit over top of the demand signal and harmonize that load acceptance decision between asset and non-asset, it drives a significant amount of profit potential for the organization. So if you talk to any CEO of a carrier that has a fairly significant size brokerage operation, you're going to hear at least one war story of, hey, the brokerage accepted a load, seemingly good margin on that load, put it on a competing carrier that was going down the highway, it's the same highway that we had one of our empty trucks repositioning itself to go to pick up their next load that they could have hauled, right? So breaking down that silo at the load level and scaling that up to the network drives significant savings. I think finally, breaking down tribal knowledge and inherent bias within the organization of how individual planners and dispatchers operate, and more importantly, it provides some inherent stability or risk aversion of that knowledge walking out the door, right? So I'm talking to a lot of VP of operations and chief operating officers of carrier operations, and one of the significant risk is a very tenured planner that has a vast knowledge of the network and customers that they lead. It is a fire drill to try to keep the network operating profitably, because there were so many decisions that were reliant that lived in that planner or dispatcher's head, that now they have to really kind of relearn and retrain people on. So providing a little bit of stability within the operation is another critical component of what OD brings to the table.
Great. And so Juliana, Joe, Zach, thank you guys as always. We have had several questions come in. We're not gonna be able to get to all of these, but I want to touch on a few. There's a few technical questions, and then there's a few commercial questions. The first one here, I think is really good and an important one to touch on is, the question is, what is the source of uncertainty and how is it taken into account in the training and live decision-making optimization? And I'm going to defer that to either Juliana or Joe.
I can take this one. So we can model various types of uncertainty, and honestly, whatever the most pertinent uncertainty that you want to be robust in the face of is what we will model. The main ones we see in our problem is travel time uncertainty and load profile uncertainty. So given you are sitting here today and you have 70% of your network booked out tomorrow, 40% booked out the day after, 20% the day after, whatever the booking profile may be. We need to generate scenarios that are representative of loads that will be booked into your network, or are likely to be booked into your network, in order to incorporate that in our future plans. And that's how we do both our training and how we would recommend load acceptance decisions that make sense in a variety of scenarios that are trained on what we expect to be coming soon in your network.
And by the way, I just want to add to that, it's not only learning the number of loads, but the full profile of these loads. Everything that I was mentioning before. What is the origin, destination, pickup window, likely revenue, permits that will be required, the type of commodity. So it's even more complex than just the number. We need to learn the full profile of the loads that we are expecting to see in the future.
Great. And then one final question. There's one other technical question, sorry, was on the historical, when we're talking about pulling in historical data to train, how do we think about the look back period, how far we go, and how do we think about seasonality when we're determining that period?
So I can take on that. So to learn about seasonality on the demand profile, ideally, we have more than 1 year. This is ideally, so we can learn about low season, high season, and etc. But this is just for the first training. This is one thing that I want to emphasize. We keep updating our models every day. So even after the offline, the historical data is just to give us a quick start. It's just to do the initial calibration. But then after we are connected and we keep seeing your actual demand day in and day out, we update our models daily. So even if we don't have more than 1 year, it's more than enough. And also demand change. We are going to, if your baseline increases, if you have a new account and we start seeing these new loads, we are going to pick up on that very quickly without you need to do any sort of interference. The same goes the other way. If you lose an account, it's going to be reflected in your demand, and our models are going to pick up on that. So ideally, 1 year and more, but even if it's less than that, I would say at a minimum 3 to 4 months, and then we can keep learning.
Great, thank you. And Zach, a couple questions here on fleet sizes. Just speak briefly about our profile of who really can benefit from something like this.
Yeah,
fleet size.
absolutely. Very, very quickly. I mean, anywhere from the low watermark where the solution can be applied is kind of your 50 truck and north fleet. I mean, we have some of the largest carriers in the nation as our customers, and but work with carriers all the way down to 50-ish trucks with a brokerage operation bolted onto it.
Great. So this has been great. There's several more questions that we'll respond to offline. We promise, just being mindful of everyone's time here today. Thanks so much to the team, and thanks for everybody that registered and is listening in. We will circulate the recording so you have it. And if there are any other questions, obviously, please feel free to reach out to the company, and we will get back to you right away. With that, we're going to sign off. So everyone, enjoy the rest of your day. Thank you.
Thank you.
Thank you all.
Thank you.